Can two agents that share no memory still improve each other's answers? Welcome to AI Agents in Depth, Episode 10, Multi-Agent Collaboration. By the end, you'll wire two agent instances into a live proposer reviewer loop that verifies and approves its own output. Last episode, the voice state machine gave one agent a voice. Listen, think, speak. Now two agents talk to each other. Chapter 10, Thesis. Group intelligence can exceed any individual, but only when each agent contributes distinct context and distinct tools. That qualifier is the whole lesson. Section 10. 1 gives one test. Does the reviewer introduce information unavailable at generation time? If you can't name it, don't add the agent. Huang et al. Eichler 2024. GPT-4 self-correction without external feedback decreased accuracy. The model flipped correct answers to wrong more than the reverse. Zero new information, zero gain. Tran and Kiela 2026 confirmed it. Equal compute. A single agent beats 5 multi-agent systems on reasoning. Debate on identical text adds zero information. WebGen agent gave its reviewer rendered screenshots. Genuinely new signal. Claude 3, 5 Sonnet jumped from 26, 4 to 51, 9%. New information equals gain. That's the only equation that works. Even when a reviewer adds real value, there's a cost. Anthropic's multi-agent research system uses roughly 15 times the tokens of a single agent run. That's the bar. Section 10. 1's heuristic. 2 or 3 roles, context under 50% share. Many parallel subtasks, isolation needed, non-shared. EP10 uses non-shared. Only the proposal text travels. Your turn. Pause here and name the new external signal a reviewer will access. Then press Ctrl-Shift-E to open the Explorer. The answer, the word count function. Our reviewer calls it to verify numerical claims. Real external verification, not rereading text. That's why this topology passes the decisive test. Chapter 10, Section 10. 2 captures this loop in one diagram. Let's open it now. Proposer drafts. Reviewer receives only the proposal text, not the proposer's full conversation history. It replies approved or a one-paragraph critique. The max rounds guard stops the loop if they disagree indefinitely. Proposer's system prompt says to draft and end with final answer. Reviewers says to verify claims with word count, then reply approved or critique. Same conversation function, same fake LLM, different system prompts. The role lives in the system prompt, not the weights. 2 calls to conversation, 2 distinct agents. The handoff package carries exactly 3 things: task description, confirmed facts, and file paths. Never the proposer's full trial and error. The book's translation manager experiment proves this. Each chapter agent receives only the glossary file path, not the glossary agent's conversation. The reviewer's context stays clean and independent. Massed research studied 150 multi-agent traces across 7 frameworks and found 2 mirror failure modes: premature termination and runaway loops. Both failures share one cure: explicit stop conditions. Set max rounds to 5. Return the best proposal when time runs out. A usable partial answer beats an infinite loop. Your turn. Trace the loop and find both places it can exit. There it is. Approved ends the loop cleanly. Max rounds guard is the other exit. You know both stop conditions before writing a single line of code. 2 agents, 1 difference, their system prompt. Let's write the proposer's brief, then the reviewer's brief. There's the whole role split. The system prompt is the role. The reviewer's contract is strict, reply approved, or 1 critique naming the error. We stub the brain so you can watch the loop. Swapping a real model in is 1 line. 1 deterministic stub, 2 behaviors. It branches on the role text in the prompt. The role lives in the prompt, not different weights. Now the loop. The proposer drafts, the reviewer checks, the proposer revises, until approved or the guard stops it. Each reviewer call is a fresh message list. The proposer's history never transfers, only the proposal text. The reviewer runs the word count tool for a real, new signal. Each role takes its own model hook, so a test can swap in a deliberately wrong proposer. Let's run it. 1 task, and watch the 2 agents talk until the reviewer signs off. There's the exchange. The proposer counts 4. The reviewer runs word count itself, then replies approved. More rounds only help when the reviewer brings a new signal, not repetition. Your turn. Change the task to 3 words, then run it. Watch the reviewer verify, then approve. Three words in, approved out. You just ran 2 agents collaborating, each still just an LLM, its context, and its tools. Next, we prove it green. First, the happy path. 2 agents should agree fast when the draft's already right. This test runs collaborate on a 4-word task. It asserts the answer holds 4, and the last review reads approved. Convergence proven. Now the real test. Force a wrong draft. Check the rejection first. A green happy path proves nothing. The proposer claims 99 words. The reviewer runs the word count tool, sees 4 and refuses. A cascading error looks consistent everywhere, so verify against the tool, never agreement. Time for the truth. Run the whole suite. 10 episodes of code, 1 command. Every test passes. The 2 new ones prove the loop converges and rejects. Green across 10 episodes, all offline, all deterministic. Back to episode 1's formula. See what every agent in our loop still is. Agent is LLM plus context plus tools, composed twice here. The team beats the individual, only when their contexts and tools differ. Same formula, now a team. Your turn, run the full suite yourself. RAG, tools, evals, voice, teamwork, all the same 3 parts. That's every episode, green. You built an agent from scratch. Congratulations. Share this course with someone learning agents. You finished the series. You built a proposer reviewer loop from scratch. You mapped both agent roles back to LLM plus context plus tools. The same formula from episode 1, now composed twice. You designed a message schema that hands off just the proposal text, not the full conversation history. And you identified 2 failure modes: disagreement loops, stopped by a max rounds guard, and context drift, prevented by non-shared context. Pause here and try this. Change the task string inside collaborate to a longer sentence of your choice, lower max rounds to 2, then run Python pytest q in the terminal. Predict first, will the loop converge or hit the guard? Check whether your prediction matches. Quick check. According to Wang et al. Eichler 2024, what happens when GPT-4 self-corrects without any external feedback? Accuracy decreases. The model changes correct answers to wrong ones more often than the reverse. Same model, same text, no new information, no improvement, and often regression. Next question. What are the 3 parts of the handoff package between non-shared context agents? Task description, confirmed facts and constraints, and references to structured artifacts. Never the sender's full message trajectory. That's all 10 episodes. You've built a complete agent, from a single LLM call all the way to a multi-agent team. Share this series with a developer who's ready for it.